Hey everybody, I know that I said that I'm going to be recording our Google Meets, and had I remembered to do so, I would be saving myself a lot of time right now. So yesterday I did not record the Google Meet. It's something I'm going to have to work on and get used to doing. But there were two specific questions that came up. I want to address those in this video so that everybody has the same opportunity to see what we discussed in class yesterday. The two questions that came up were from 1.1. It was the notes from Tuesday. And it was question number 13 and question number 15. So I'm going to address both of those, go over to the solutions, and then I'll get this posted for you guys. So for question number 13, that question is asking us to find all points that have an x-coordinate of 2. So we know this much right now. We have an x-coordinate of 2. And we're looking at in relation to the point -2, -1. And we're looking for all points that have a distance of 5 units from -2, -1 with that x-coordinate of 2. So the only thing we're missing is some y value or values in a second ordered pair. So we know that it has to have an x-coordinate of 2. That is fixed. But we need to find what that corresponding y value or values may be. And we're going to use the distance formula. So recall from our notes, the distance formula is the difference in the x-coordinates, quantity squared, plus the difference in the y-coordinates, quantity squared. And then you take the square root of that, and that results in the value of the distance. What's nice about this problem, and it may not have stood out immediately to everyone, we have one ordered pair, we already have the distance, and we also have a second ordered pair, but we're actually solving for that variable y. So the way that I approached this problem yesterday in class, I was doing it on the fly and I wasn't thinking ahead. There is a second approach, and I'm going to use the second approach today. It's not really going to be much more time saving, but it's just a different way to go about this problem. It still results in the same answer. So let's go ahead and substitute in what we know, and then we can solve this problem. So we do know the distance is 5. We are given an x2 value of -2, and then we have an x1 value of +2, and then we have that quantity squared. We have a y2 value of -1. We have the unknown quantity for y, and then we have quantity squared. So let's simplify this. -2 minus 2 is -4. -4 squared is +16. And then we have this plus -1 minus y, quantity squared. Now, those of you that were in the meeting yesterday, I did expand that -1 minus y quantity squared. We're going to do it today without expanding that. I meant to show this to you yesterday, and I failed to do so. I wanted to show you both ways to solve it. So where we're at now, what we can do is we want to get rid of this square root. So we'll get rid of the square root by squaring both sides of the equation. And so now we have 25 is equal to 16 plus -1 minus y, quantity squared. We can subtract the 16 from both sides. And here, since we have this quantity squared on the right all by itself, and we have 9 on the left-hand side, we can take the square root of both sides of this equation. So now what we get is plus or minus the square root of 9 is equal to -1 minus y. Well, the square root of 9 we all know is going to be 3, so we have plus or minus 3 is equal to -1 minus y. We can add 1 to both sides. So in one case, we're going to get +4, and in the other case we're going to get -2, and that's going to all be equal to y. So our solution set will be the ordered pairs 2, 4, and 2, -2. And so there's the solution to number 13. Those are the only 2 points that have a distance of 5 units from the given point of -2, -1. The next question that came up was number 15. And number 15, what I like about it is a lot of you guys are very comfortable with concrete examples. This is more of an abstract example. We're taking into consideration every single conceivable square. So we all know a square, all four sides are the same length. So what this problem looks at is every possible square, all the infinite squares that you could come up with. It simply says to find the midpoint of each diagonal of a square with side length s. Draw the conclusion that the diagonals of a square intersect at their midpoints. The way that I kind of described this yesterday, if you imagine a coordinate plane, and if we place a square of indeterminate size inside this coordinate plane with this lower left corner at the origin, so we have this corner is at 0, 0. Each side length of this particular square is s units, and I'm trying really hard to make sure those don't look like 5s. So what that means is this bottom right-hand corner, if we think of it in terms of ordered pairs, we're moving s units to the right, so this ordered pair becomes s, 0, because we didn't move any units on the y-axis. Then if we move vertically to the upper right-hand corner, the x-coordinate remains s, but now the y-coordinate is also s, because we're still s units to the right and then s units up. And then the corner that's to the upper left is going to have an x-coordinate of 0 and a y-coordinate of s. So what we have now is enough information to find the midpoint of each diagonal, and then we can also then draw the conclusion that the diagonals intersect at the midpoints. So let's start at the origin and move to the upper right-hand corner. We're going to look at this diagonal. We want to find what is the value of that midpoint. So remember, the midpoint formula is the sum of the x-coordinates divided by 2, and then you have the sum of the y-coordinates divided by 2. So we're looking at the diagonal that goes from the origin to the upper rightmost corner. We'll substitute in our values. So our x1 value is 0, our x2 value is s, and we divide that by 2. And then with our y-coordinates, it's going to be the exact same values, 0 plus s over 2. And that's going to simplify to just s over 2, s over 2. So the midpoint of that yellow line that I've drawn is s over 2 and s over 2. Now let's look at the midpoint of the diagonal that goes from the upper left corner down to the bottom right-hand corner. We have the midpoint is the sum of the x values. So again, it's 0 plus s in this case over 2. And then the y values is s plus 0 over 2. And that simplifies to s over 2, s over 2. So we notice here that in both cases, both diagonals have the exact same midpoint. So that means that they have to intersect at that same point in space, in the two-dimensional space of the Cartesian plane. So at s over 2, any square that you draw, whatever s happens to be, it's the side length of that square divided by 2. So if that square was 4 units long, let me change color, hopefully you can see this. If this square is 4 units by 4 units, the midpoint is going to be at 2, 2. So it's half the length of each side. So this is just kind of getting you to think a little bit more abstractly about every conceivable square, but that's how you prove that squares do intersect at, or the diagonals of squares intersect at their midpoints. Those are the only 2 questions from yesterday. Remember, if you guys have other questions, I know you have 2 sets of notes now, 1.2 and 1.3, and we'll look over those on Tuesday if you have questions. But if you come up with something in the meantime between now and then, feel free to send me a message on Remind or contact me through Google Classroom. You can contact me by email, and I will see you guys on Tuesday. Do not forget that when classes begin on Monday for all of Perry County schools, your Google meeting will be open during our regularly scheduled class period. So during second period on Tuesday, I will have a meet open. I'll send it out to you guys just to remind you, but it'll be open during our regularly scheduled class time. And if you'll give me a second, I'm going to pull up an email and tell you what that time is, because they are really odd this year. Okay. Second period this year will run from 9:46 to 11:17. So from 9:46 to 11:17, this Google Meet will be open. I say that, but it will open at 9:46. If 10 of you show up and we talk about whatever questions you have, and then you guys bug out, and I've still got 45 minutes left, I'm probably going to close the meet. And if you decide at 11 o'clock you need to talk to me about something, just shoot me a message and I'll open it back up. But we'll go over more of these things on Tuesday when we meet each other again. Hope everybody has a wonderful weekend. Send me your questions, and I will be talking to you soon.